Myself Nitish here for part 4 video, which will be going to deal with the part 4 video. Is it not? Let me check. It is will be going to deal with it's part 4 video. Part 3 is completed, so part video will be again going to we are going to have a topic of disinfection as well as other miscellaneous treatment processes. Okay, so now need for the disinfection mechanism, everything we are discussed among here in this particular classes. So now we will move to some of the requirements of the good disinfectant. We completed advantage and limitations of common disinfectants. Now some good requirements. What should be the good requirement for a good disinfectant? What should be a property also you can say. So they should be destroy all harmful pathogens and make it safe for use. That will be the first point, which will be the requirement. This is the first requirement of good disinfectant. That means whatever the disinfectant you are using, it should be destroy all harmful pathogens and make it safe for use. They should not take more time to killing the bacteria. They should not take more time to killing the bacteria. So that is also very important. Contact time should be very less. Okay. They should be economical and easily available. They should be economically and easily available. They should not require high skill for their application. And after treatment, the water should become toxic and objectionable. Okay. Third point is should be economical and easily available. Whatever the disinfectant you are getting, that should be very economical and it should be easily available. It should not much cost. They should not require high skill for their application. After treatment, the water should not become toxic and objectionable. Okay. Objectionable. After treatment of the water, it should not be toxic. Whenever you are using that disinfectant as a disinfectant, if for example as a chemical, that should not be a toxic after the treatment, and it's not objectionable to water users. Okay, so that is an important concept. And concentration should be determined by simply and quickly. The concentration should be determined by simply and quickly. So that is what a very good disinfectant requirements. Okay, this is a very good disinfectant requirement. And forms of the chlorination. One is as a bleaching powder. That is already we discussed. But if the question is asked like what are the forms of chlorination, that is as a bleaching powder, as a chloramine, or a chlorine dioxide, or a free chlorine gas, and as in this one my topic left out in the part 3 video. So forms under liquid chlorine, and we discussed about all the methods in the previous sessions. So that is what your chlorine reactions. So hypochlorine, chlorine, chloramine, chlorine dioxide, breakpoint chlorination, residual chlorine, everything we discussed in the forms of chlorination. So that is what about today, which we are not completed, that will be discussed. And we are discussed now about requirement of good disinfectant and forms of the chlorination. Okay, so now we'll move on to another topic, that is miscellaneous treatment. Other than that, if any treatment is required, miscellaneous treatment processes. That is, normally we are not putting for all the treatment plants. For example, if this is a treatment which is required for an other process. For example, if you go to villages, if you go to not villages, if you go to the iron-borne areas, so then iron removal is very important. If the water is under fluoride content, which is in the region wise, that region we should be miscellaneous treatment where the defluoridation should be done, or fluoridation is required of, then fluoridation is done. That is what the process. And if the water is hard, some of the region water will be hard due to presence of calcium and magnesium kind of places, we should remove the hardness of the water. So this is what the treatment. If the treatment required any kind of extra water is required, extra treatment like fluoridation, defluoridation, or removal of hardness, or microfiltration, nanofiltration, such kind of topics will be discussed further processes. So now now we are going to discuss now we'll go and concentrate on hardness, that is softening. Water we have to soft. That is the topic which is softening the water. If the water is hard, the opposite word is soft, right? We are softening the water if water is hard. So hardness in the water prevents in the formation of sufficient foam when you used with a soap. It is caused by a certain dissolved salts. You know that the water, how the hardness of the water, that is hardness in the water is the formation of sufficient foam. Like say definition, you can say that hardness is water prevents that formation of sufficient foam when you use with the soap. That will be the one identification of the we can tell that it is water is hard, and it is caused by a certain dissolved solids like salts of what, calcium and magnesium, which form scum with the soap and reduce the formation of the foam, which will be helps to removing the dirt and dirt from the, which will be helpful to reduce from the dirt from the core. These salts keep depositing on the surface of the boilers, and thus it form the layer is known as scales, which is reduce the efficiency of the boilers. There are two types of hardness. So we'll discuss. Are you getting now? The hardness is important, that prevents the formation of sufficient foam when with the soap. It is caused by certain dissolved solids of calcium and magnesium, which forms scum with the soap and reduce the formation of foam, which will help in the removing dirt from the clothes. These salts keep on depositing on the surface of the boilers, and thus forms a layer is known as scales. With that is what the process. And if you further discuss, there will be two types of hardness. One is temporary hardness. Temporary hardness is due to bicarbonate of calcium and magnesium. Okay, temporary hardness is due to bicarbonate of calcium and magnesium. It's only due to bicarbonate, can be removed by boiling. It's easily removed by boiling of water or adding the lime to it. By boiling the carbon dioxide gases are escaped, and insoluble carbon dioxide deposit, which cause scaling. Okay, so you can see if the hardness of the water, if you boil it, the carbon gases dioxide gas will be escaped, and you can see that in the scaling, which will be white layer will be formed. So that is the reaction will be like this: CaHCO3, that is your bicarbonate of calcium, and this is MgHCO3 is twice is a bicarbonate of magnesium. When you go for a heating process, that CaCO3 will be deposited and CO2 will be deposited. That is scaling, and CO2 will be passed, and only H2O will be remains. That is easily we can remove. So that is what your temporary hardness. It is caused due to bicarbonate of calcium and magnesium, as this can be easily removed by boiling of water or adding the lime to it. Boiling the carbon dioxide gases escapes the insoluble carbonates and deposits, which causes scaling. Okay. So now MgHOC, that is MgHOC3 twice, which will be also MgSO3 will be deposited and CO2 will be escaped gases, and H2 will be remain when it is boiling. And when it is when you are going for adding the lime, what happens? CaHCO3 twice, that is your bicarbonate of calcium, uh, plus CaOH2 lime, that is your lime, will be causes 2CaCO3 forms, 2CaCO3 forms, and H2 2H2O will be remains. So that is your when the adding of the lime. So this will be removed. Your bicarbonate of calcium will be removed. That is causes the hardness of the water. Same MgSO3, CaCO3 plus MgCO3 plus H2O when it is added with the lime to bicarbonate of magnesium. I hope you got it, this equation easily. Very simple equation. Not much work in that. So this is about your first method, that is your temporary hardness. Temporary hardness is caused due to what? Bicarbonate of calcium and magnesium, as this can be easily removed. Okay. So now if you further move on, if we further move on to if we further move, so that we have another hardness, that is permanent hardness. What is permanent hardness? Permanent hardness, if sulfates, chlorides and nitrates are present, they cannot be easily removed by boiling, and so such water requires water softening method, and this type of hardness is known as permanent hardness. It is removed by zeolite method. It is removed by zeolite method. Okay, that is ion exchange method. That is your how it is caused. It is due to sulfates and chloride and nitrates are present. If sulfate, chloride and nitrates of ions are present and they cannot be easily removed by boiling, and so what we have to do means water required for a softening method, and this type of hardness is known as permanent hardness. And permanent hardness, this type of hardness is known as your permanent hardness. Okay. Permanent hardness is required. What is required? It is required removed by zeolite method. Zeolite method is also named as ion exchange processes. Ion exchange process. Okay, we can say ion exchange process also for this. Hope so clear. So now removal of permanent hardness. Now you got it. Now temporary hardness, how can we remove? It is removed by boiling, right? Boiling or heating, or what we are doing, heating or adding the lime, we can do that. We can remove the temporary hardness, simple. But permanent hardness, we have to remove sulfate, chloride and nitrate, isn't it? This chloride nitrate can be removed only in some following process. So now removal of permanent hardness, if you concentrate removal of permanent hardness, what we have to do, cold lime softening will be there, or hot lime softening will be there. There are two processes will be there. That is cold lime process and hot lime processes. What is cold lime processes? That is when the cold lime softening, when the hydrated lime, that is CaOH2, is added to the water being treated ambient temperature, the following reactions occurs. This is the following reaction. What is following reaction? When hydrated lime, that is when you CaOH twice, if you add to the water, what happens? You see, CO2 plus CaOH2, CO2 plus, that is hardness, CO2 plus your lime, OH2, so that is CaOH2 CaCO3, H2O, CaCO parts, your precipitates will be CaCO3, H2O, right? And this is one, and CaOH, COH, if the hardness, this is the kind of hardness which I am showing you. That is the kind of hardness here. This will be kind of hardness. Now, if CaOH3 twice, CaOH3 twice is a hardness, then if you add CaOH hydrated lime, 2HCaCO3 will forms and 2H2O will be forms. And MgCO, this is your bicarbonate, this is your magnesium, and this is form of magnesium. So this is the reaction will be takes place. CaOH2 that is equal to CaCO3 and MgCO3 plus 2H2O. Same way CaCO3 and MgOH2 precipitate. This all are precipitation in that. So now if you see the look out the process, see lime soda. See here what happens here. The limes in the softening process, your cold lime softening, that softening process, lime soda will be there, and coagulant is optional. If required, you can add here itself coagulant. Lime soda, when you're adding lime soda process, you can call it as also this is lime soda process. Okay, lime soda. There will be a question can be asked such a way that what is they explain the process of lime soda process. So lime soda process will be like this. So no much confusion here. Right. So here say concentrate, coagulant will be optional. You can add. So rapid mixing will be takes place here. Rapid mixing. So after that, flocculation and sedimentation will be there. So recarbonation basin will be there. Then filtration. This is the process will be adopted in the softening, that is lime soda process. So when you come to hot lime softening, hot process softening is usually carried out under pressure. Okay, this is only you have to think about that. Its hot lime process will be under pressure, and it is elevated temperature around 227 degree F up to 227 to 240. That is in terms of degree Celsius. It will be 108 to 116 degree Celsius, leading to softening reaction go essential completion. So that is your leading softening reaction go that is essentially to complication. It involves some reaction except the raw CO2 is except the raw CO2 what happens, it will be vented and does not react. The use of lime and soda ash permits hardness reaction down about 8 ppm. Hardness reaction down around 8 ppm of CaCO3. Magnesium is reduced up to 2 to 5 ppm of the lower solubility of magnesium hydroxide at the elevated temperature. Okay, around elevated temperature is around how much? 108 degree to 116 degree. So that is what. If the proper chemical control is maintained on the lime feed, the calcium hardness may be reduced. If the proper chemical control is maintained on the lime feed, the calcium hardness may be reduced up to 35 to 50 ppm. Okay, so magnesium reduction is a function of amount of hydroxyl OH minus alkalinity excess maintained. So when the magnesium reduction is a function of the amount of hydroxyl OH minus alkalinity excess maintained. So that is an important concept. So now if you concentrate nano that is in the, if you say that nanocarbonate and permanent calcium hardness, if present, is not affected by the treatment with lime alone. That is nanocarbonate and permanent hardness. If present, it is not affected by the treatment lime alone. Okay, that is your nanocarbonate and permanent calcium hardness. If present, it is not affected by treating the lime alone. Nanocarbonate and magnesium hardness is present amount of greater than 70 ppm. If it is greater than 70 ppm and excess hydroxyl alkalinity about 5 ppm is maintained, the magnesium will be reduced about 70 ppm, but the calcium will be increases in the proportion to the magnesium reduction. Okay, this is about your what to say, that is your hot lime softening. So if we concentrate on design consideration of this lime soda processes, the lime soda ash softening plants, that softening process may carried out by a sequence of rapid mixing and flocculation and sedimentation or in a solid contractor. So that if figure you can see here, rapid mixing, flocculation, sedimentation, recarbonation and filtration will be the your design process will be contained. That is once again by sequence of rapid mixing, flocculation and sedimentation or in the solid contractors. Okay, in this solids contractor of rapid mix or flocculation and sedimentation occur in a single unit. In the solid contractors, the rapid mix, flocculation, sedimentation occurs in a single unit. Detention time in the flocculator is important to allow particles to come in a contact with each other. The minimum time recommended is 30 minutes. How much minimum time is 30 minutes in the softening. That is, detention time in the flocculation is also important. Why important it is? It is important to what? To allow the particles to come with a contact. Particles should be contact with each other. For that you have to give a detention time. That is what? How much mentioned? That is 30 minutes you have to mention. You have to give at least. Our recommendation is 30 minutes. So this is about your process of rapid mixing. And also consider under design consideration. Clear, right? So we'll move to some of the solid. There are two methods. One is solid contractor, right? So that solid contractor will be such a way that, so here you can see the figure. The sedimented first will be that what driving belt will be there here. So this is the driving belt and your motor is fixed. So what is the duty? That will be the mixing will be done here and raw water feed inlet will be here. So that you can see here raw water inlet feed will be there and chemicals like what your soda or lime and coagulant inlet feed will be here. Soda ash inlet feed will be here. So filtered softened water will be outlet will be, see you can see the outlet will be here. Wood fiber filter will be there. See here wood fiber filter will be fixed and stirrer pedals will be there. Stirrer for flocculation purpose. Here stirrer, this is stirring processes here and inlet chamber. You can see that outlet chamber will be, this one is an outlet chamber and this one is an inlet chamber. This is inlet chamber, this is outlet chamber and it is fixed with a one stand, so that here you can sludge outlet, you can see there is a sludge outlet come out here and the sedimented sludge CaCO3 MgOH precipitated, that precipitation will be done. Okay, I hope so. This is you can easily understand. So now when you concentrate on another method, that is hot lime softening, when you go for an hot lime softening, the raw water feed light will be here. You can see that is raw water feed inlet will be there. So this is the inlet feed. So what happens? Superheated steam will be inlet. You can pass to here because it is a hot lime process. No. So and chemical, where chemical enters? The chemical enters in this way, the chemical, whatever your lime soda processes, lime soda, and the tank will be provided. This is called a reaction tank. Right, this is a reaction tank. So this reaction tank, and there will be chemical sediment. This is a conical sedimentation tank will be provided, conical sedimentation, and you can see here the sludge precipitation, that is your CaCO3 and MgOH2 precipitants will be there. Precipitated sludge outlet will be here. After that, once it is your softened water will be passed with a fine layer of fine sand and coarse sand gravel, as you studied in the sand filter, rapid sand filter or pressure sand filter. That will be passed to sand filter here. The filtered softened water will be come outlet from here. I hope so you understood this process easily. Okay, so now we'll move to another method. Before moving to another method, just I'll recall this method once again for you. So that is we studied in the miscellaneous treatment processes. That is your hardness of the water. In that we studied temporary how can be removed, that is only by heating and adding lime, and permanent hardness will be sulfate, chloride and nitrates will be there, so that you can go for a zeolite process or ion exchange process and lime soda process for the softening. What is in the lime soda process? We can say cold lime processing, as well as we have a hot lime processing. Hot lime processing, you can see here, around 227 to 225 elevated your temperature, around 227 to 240 degree, that is 108 to 116 degrees Celsius will be given to that. So what happens that time, with everything I explained, that is for that the different concentration you have a rapid mixing and flocculation sedimentation reactors will be provided, and detention time will be given for the contact, and this will be the chemical and chemical process will be taken inside. So this is about your lime soda process. If you come to advantages of the lime soda processes, there will be two advantages. There will be some of the advantages will be in the lime soda. That is, one is the pH value of the water treated by this process being bring down to 9, and which results that decrease the corrosion of the distribution system. Okay, so less quantity of coagulant will be required. So if this process is adopted, coagulant will be less, and removal of iron, manganese also some extent. Okay, iron and manganese. Reduction of total minerals content in the water, that will be the another advantages. Hardness of water reduced up to 40 mg per liter as CaCO3. Magnesium up to 10 mg per CaCO3. The process is economical. This process is mostly suitable for the tubed and acidic water, where it will not possible to adopt zeolite processes, where you are not provided zeolite process, then you can use this processes. The pH value of the water treated by this process bring down around 9. Okay, and less quantity of coagulant is required for this if the process is adopted. And removal of iron, manganese some extent. Reduction of the total minerals of the water will be there, and hardness can be reduced up to 40 mg per liter of your CaCO3, and magnesium we can say around 110 mg per liter. And this process is economical and not suitable for it's most suitable for tubed and acidic water, where it is not possible of zeolite processes. This is about your advantages of the lime soda process. This is what is advantages of lime soda processes. Now if you concentrate on the disadvantages will be one of again major criteria, that is disadvantages. If you take the large quantity of sludge formed during in this process, and to be disposed of by some suitable method. The large quantity of sludge formed during this process, and to be disposed of by some suitable method. This process requires skilled supervision for a successful working, and if recarbonation is omitted, a thick layer of calcium carbonate will be deposited. Okay, deposited. deposited in this method. So in this process requires skill supervision for a successful working. If recarbonation is omitted, then thick layer of calcium carbonate will be deposited, filtering media, distributed pipes, etc. So that is one process. This is about your disadvantages. That is large quantity of sludge is formed here. What to do that for sludge? That is disposed of some suitable method. That is one disadvantage. And process of required killing some skilled supervision for successful working. Okay, recarbonation is omitted. Recarbonation will be there. For that, you have to take care. So, if you concentrate on zeolite process, next process is called zeolite process, or else you can call it as ion exchange process. Also, you can call it very important in terms of water softening. That is zeolite process as well as ion exchange processes. What is ion exchange process and zeolite process? If you study that, if you concentrate what is zeolite process, what is ion exchange process, just concentrate. I just will see now. The ion exchange method of water softening has been used extensively in smaller water systems, where ion exchange method of water softening has been extensively used in the smaller water systems and individual homes. Okay, it is based on the ability of ion exchange resins. The resins will be there here. This ion exchange resins will be under this process. Zeolite is exchange one ion from exchange to resin. Zeolite to exchange one ion from water being treated of another ion that is in the resin. Zeolite resin exchange from sodium ions for causing hardness, ion causing hardness. What it will do, the zeolite resin exchanges sodium ions for an ion causing hardness in the water, such as calcium, magnesium. Sodium is one of the important component of softening salt, with the chlorine being other. Okay, so that you can see here NaCl solution inlet. That is what is NaCl means your sodium ion, sodium or chlorine being together added. So sodium and chlorine and hardened water will be inlet here, and this is the zeolite where the wash line will be further and soft water will be come out there. So that is what is the process here. The zeolite is an exchange of one ion from an water being treated to another ion that is in the resin. Zeolite resin is exchanges sodium ions for an ion causing hardness. Okay. So this is one of the process. If you look up the chemistry of an ion exchange reaction, what chemistry is behind about the ion exchange process, you can see now the following chemical reaction show the exchange of the X-ray presents to the zeolite exchange minerals. So before going to that, we can see here, so the pre-board or raising sludge will be there. And so here this is upper distribution. Top connection will be service inlet, backwash outlet, and rinse inlet. And bottom connection will be service outlet and backwash outlet and wash chemical rinse outlet. Freeboard or rising space, upper distribution, chemical inlet, chemical distribution, subsurface washer optional will be there. The lower distributor with strainers, concrete subsoil will be filled at the bottom, and soft support will be provided. The lower distribution strainers will be provided at the bottom, your bottom connections, and exchange resins will be there. So this is about your the processes behind. If you look at the ion exchange processes typically used in the dissolved ionic impurities and hardness. Containment ions in the water is removed by exchange with another non-objectionable ionic substances. How? That is like your exchange with another non-objectionable ionic substances. Ion exchanges hold the retained ion temporarily and then releases to the regeneration solution. Okay, then releases to the your regeneration solution. Okay, so that is your exchanges to the regeneration solution. It is physiochemical process. You can say that is a physicochemical process in which ions are swapped between solution of phase ion. Say that is swapped. You can very importantly you can say that is where our ions are in the water. Whatever the ions are there, that is a process that is swapped by physicochemical process. Solution phase and your solid resin phase. Solid resin phase and solution phase. That is your swapped between that solution phase and resin solid resin phase. The solid resin is typically an elastic three-dimensional hydrocarbon. Okay, that solid resin is typically elastic and a three-dimensional hydrocarbon network. You can see in the figure and containing large number of ionizable groups electrostatically bound to resin. A synthetic resin is relatively well-defined exchange capacity. Exchanges ion held in electrostatically on the surface with ions of similar exchange. Similar charge will be dissolved in the water. So this is a polymer backbone and functional group. So that is dependent upon the selectivity of the ions. Okay. So that is the solid resin is typically an electrical three-dimensional with ions of similar charge of dissolved in the water. The target ion removal is accomplished by continuously passing the water under pressure. Okay, the target ion is accomplished by continuously passing the water under pressure. Okay, that is under pressure. That is your target ion removal accomplished by continuously passing under pressure through one or more columns packed columns should be there, the packed with an ion exchange resins. Okay, so your chemical reaction, as I said, you can see here these reactions represent Cushion change the exchange of positive ions to replenish the sodium ions used. The units need to be recognized with a material containing high amounts of sodium. Normally salt brine. This allows a resin to be reused many times. Okay, hope so. Many times. Okay. If you look at the removal of carbonate hardness, removal of carbonate hardness, that is your CaHCO3 twice and Na2X will be your CaX and NaHCO3 will be the that is your carbonate hardness, if you say, will be the reaction, and your magnesium MgCO3 and Na2X will be the reaction will be like this. And removal of non-carbonate hardness, you can say CaSO4 and Na2X. That is your non-carbonate ions. So this will be the reaction, and CaCl2 Na2X will be the reaction will be like this. MgSO4 plus Na2X will be like this, and MgCl2 plus Na2X will be so on. So this is about your reaction under the carbonate hardness. Also understood. So now your ion exchange, the ion exchange softening process does not alter water or pH of the alkalinity. One of the important thing you have to remember that our ion exchange process or zeolite process will be not alter the pH in the or alkalinity in the water. However, stability of the water is altered. Stability of the water is altered due to thermal of calcium and magnesium and individual and altered removal calcium and increased dissolved solids. So that is little altered. Individual solids. For each ppm of calcium is removed. So each ppm of calcium is removed and replaced by sodium. Right. That because sodium is an we are giving ions to them to exchange with the total solids increased by 0.15 ppm. Okay. So for each ppm of magnesium removed and replaced sodium. So each ppm your magnesium is removed and replaced sodium. The total dissolved solids will be increased up to 0.88 ppm. Okay. The measurement is used to express water hardness in the ion exchange process differs from the units that are normally used in the lime soda process. The measurements used to express water hardness in the ion exchange process differ from the units that are normally used in the lime soda processes. Hardness in the ion exchange process is expressed again per gallon. Your hardness in the ion or rather than mg per liter of the calcium carbonate CaCO3 will be expressed. Okay. So measurement of the expressed hardness is ion exchange process differ from that units that is normally used for the lime soda processes. Also you understood. Very simple. And one of the most commonly we have used it. So now if you look at the advantages and disadvantages in this processes, the sludge is not formed, hence problem of the sludge is does not arise. Okay, here one more important concept is advantages. In this processes sludge is not formed. And problem of the sludge disposal does not rise as you compared with the comparison. You can say that as if you compare with that another you can say that is lime soda process. There is sludge will be more. Here the sludge will be less. That is one of the important reaction you can say. Next, it can be operated easily and no skilled supervision is required. So its operation is easy. It has happened by that the hardness of the water is reduces 0 and hence it is used for a boiler and textile industries. Especially in the textile and boiler industries, we can use so that the hardness will not be there, it will be 0. So there is no formation. And the process is economical where the salt is cheaply available. Sodium is cheaply available, so your process will be little economical. The load on the zeolite can be reduced by combining it lime or aeration processes. If you combine with the lime or aeration processes, the load on the zeolite can be little reduced and process is most automatic. One more important is that is most automatic. It operates by its own. So more skilled supervision will not be required. So this is about your advantages. If you say 1, then it will be sludge disposal will be very less. No sludge disposal and no skilled supervision. Hardness of the water reduces. The process is little economical, so because why you are using salt is very cheaply available. The load on the zeolite can be reduced. So combining lime with an aeration of the process almost automatic. Okay, the process is almost automatic. So one more thing, if you concentrate on disadvantages will be The zeolite process cannot be used for further turbid or acidic. One of the important criteria you can say, that is zeolite process is cannot be used for further turbid or acidic water, and the zeolite process is unsuitable for containing iron and manganese. This little iron and manganese is there because it is ion exchange process. Little problem and unsuitable. Zeolite should be operated carefully to avoid injury or damage to the equipment. That should be, you have to carefully have to see that there is a important concept. Okay, so this will be the one of the important concept. So in this part video I explained you two types of the ion, that is your hardness removal. One is temporary hardness removal, permanent hardness removal, and for removal of permanent hardness by lime soda processes and design consideration of that, advantages and disadvantages of lime soda processes, and zeolite process and ion exchange method, chemistry behind that ion exchange method. This process you have to explain whenever the question is asked, including this reactions and some of the things and advantages and disadvantages ion. This is the part 4 video I am going to signing off. Next video we are going to concentrate on reverse osmosis and other treatment processes. Thank you and all.